In ancient times, people revered the sun as a god, showering the earth with blessings of heat and light. But the sun was a restless god, traveling high and low in the sky throughout the year. Ancient cultures tracked these patterns of change because their lives depended on it. They did not understand the sun as we do now. To them, it was a giver and a taker of life. But there were times when the pattern was broken, times when the sun did not shine and a shadow overtook the land. Imagine how the ancients must have felt to see the sun swallowed up by an unseen thing. Ancient people believed that the sky and everything in it revolved around the earth. It was an idea that matched their experiences. It doesn't feel like the earth is moving, and it certainly looks like the sun, moon, stars, and planets are all going around us. Human beings evolved to be very good at seeing patterns. When we look into the sky, we don't just see a random mess of stars, we see shapes. These constellations serve as landmarks to observe the motion of the sun, moon, and planets. With careful observations, people discovered that the patterns of movement in the sky are predictable. An understanding of these patterns made it possible to predict the best times for planting and harvest, and thus agriculture was born. With agriculture, people didn't need to constantly hunt and gather food, so they could turn more of their time to their interest, and some were fascinated by the sky. They made observations and developed calendars to predict the seasons more accurately. Eventually, they began to predict eclipses. To understand how eclipses occur, we'll need to know something about the shape of our solar system. The sun is the central light source, and it's also the heaviest thing around, accounting for 99% of the mass of the solar system. Because of this, almost everything in the solar system orbits the sun. The orbits of the planets are nearly circular. They form a disc shape with the sun at the center. Closer to home, we see that the moon orbits the Earth, just like the planets orbit the sun. The moon's rotational period is the same as its orbital period. Because of this, the same side of the moon always faces the Earth. The moon does not make its own light, it reflects sunlight. This reflected light is so bright that we can see the moon during the day. It appears silvery white against the blue sky. The blotchy dark areas on the surface of the moon are called maria, a word that means seas. Early moon gazers imagined that these dark areas were large bodies of water. They are actually lava plains from volcanic eruptions 3 to 3.5 billion years ago. Astronomers can estimate the ages of different areas of the moon's crust by comparing the numbers of craters. Older areas have more craters simply because they've been around longer and have had more time to get hit. Because the numbers of craters in the maria are relatively low, we can tell that the maria are younger than the surrounding highlands. Turning to the far side of the moon, we see a very different landscape with very little maria. The first photograph of the far side of the moon was taken by the Russian spacecraft Lunar 3 in 1959. The first human beings to see the far side of the moon were the crew of the Apollo 8 in 1968. This side of the moon never faces the Earth. It is sometimes called the dark side of the moon. But that's not quite right, because the far side of the moon gets as much daylight as the near side, we just never see it from Earth. No matter where the moon is in its orbit, the side facing the sun is lit, and the side facing away from the sun is dark. The moon takes about 4 weeks to orbit the Earth. As the moon orbits, the bright shape we see changes. We call these shapes the phases of the moon. When we see the moon as a complete circle, we call it the full moon. The side facing us is fully lit by the sun. When the lit shape of the moon is shrinking, we say it is waning. This shape is the waning gibbous. This shape is called the third quarter because the moon is 3/4 of the way through its orbit. This is the waning crescent, the last phase as the moon dives into the glare of the sun. Half of the moon is still lit, but most of the lit side is facing away from the Earth. The new moon is difficult to see because it appears so close to the sun in the sky. When the shape we see is growing in size, we say it is waxing. As the moon emerges from the sun's glare, we see the waxing crescent. This is the first quarter. Waxing gibbous. And now the full moon, which brings us back to where we started, with the Earth between the sun and the moon. An eclipse is essentially one body casting a shadow on another body. So if the Earth is between the sun and the moon, why don't we see the Earth's shadow on the moon during every full moon? Well, for starters, the moon isn't really this close to the Earth. The distance from the Earth to the moon is about 30 times the Earth's diameter. And the moon's orbit is tilted about 5 degrees, keeping it out of Earth's shadow most of the time. Eclipses happen when the sun, Earth, and moon are in alignment, and this only happens a few times each year. When the Earth casts a shadow on the moon, we call it a lunar eclipse. Lunar eclipses can only occur during a full moon and are visible to anyone who can see the moon during the eclipse. The moon takes up to 3.5 hours to pass through the Earth's shadow. Earth's shadow is fuzzy. It has a darker umbra and a lighter penumbra. When the moon passes through the penumbra, it's called a penumbral eclipse. When the moon passes partially through the umbra, it is called a partial lunar eclipse. When the moon passes completely through the umbra, it is called a total lunar eclipse. Total lunar eclipses have a surprising quality. When the moon enters the umbra completely, it appears to turn red. This is an optical effect of the Earth's atmosphere. The same effect that makes sunsets red also casts red light on the moon during a total lunar eclipse. The molecules in our atmosphere scatter blue light and allow red light to pass through more directly. Many cultures have developed traditions about lunar eclipses. The Inca believed the jaguar was devouring the moon. They feared that the jaguar would attack Earth once it was done with the moon. So they would brandish their weapons, scream at the night sky, and encourage their animals to make as much noise as possible in hopes of scaring the jaguar away. The ancient Mesopotamians believed that a lunar eclipse was an assault on the moon by 7 demons. They had the ability to predict eclipses, and in preparation for the event, a temporary king was installed. If the demons attacked the city, the temporary king would bear the brunt of the attack, while the real king would be safely hidden among the commoners. In the African nations of Benin and Togo, we find a more positive myth. Traditions hold that a lunar eclipse occurs when the sun and the moon argue and disagree. The people encourage the sun and the moon to stop fighting and at the same time work to resolve their own disagreements with each other. When the moon casts a shadow on the Earth, we call it a solar eclipse. Solar eclipses can only occur during a new moon and are visible to anyone situated in the shadow of the moon. Like the Earth's shadow, the moon's shadow is fuzzy, with a darker umbra and a lighter penumbra. If you're in the path of the penumbra, the sun will be partially blocked and you will see a partial solar eclipse. If you're in the path of the umbra, the sun will be completely blocked and you will see a total solar eclipse. During a total solar eclipse, the entire sun is blocked by the moon. When the sun is completely blocked out, the faint solar corona becomes visible. This lasts only a minute or so, and it is the only time when it is safe to look directly at the eclipse. The corona is the outermost layer of the sun's atmosphere, a halo of plasma that extends over 1 million kilometers into space. Solar prominences may also be visible during a total solar eclipse. These gigantic loops of charged plasma are held high over the surface of the sun by strong, twisting magnetic fields. Because the orbits of the Earth and the Moon are not perfectly circular, there are times that the sun is not fully covered during the peak of a solar eclipse. Annular eclipses happen when the Earth is slightly closer to the sun and when the Moon is slightly farther from the Earth. During these eclipses, a bright ring of sunlight called an annulus appears around the Moon. The ancient Greeks saw solar eclipses as a sign that the gods were angry and believed that eclipses heralded times of disaster and destruction. The Pomo people, a group indigenous to California, tells stories of a bear that took a bite of the sun. The Pomo word for solar eclipse translates as "sun got bit by a bear." Sometimes 2 weeks before or after biting the sun, the bear also bites the moon, causing a lunar eclipse. Norse cultures imagine a pair of sky wolves chasing the sun and moon. When a wolf caught either the sun or moon, an eclipse would result. Looking at a solar eclipse when any part of the sun is visible can damage your eyes. In fact, one should never look directly at the sun. That's normally not a problem because it hurts to look at bright things. That pain is your body's defense mechanism, but it only works with bright light. Solar eclipses are dangerous because the defense mechanism is tricked. While the sun is partially blocked, your body won't recognize it as bright enough to hurt you. But the sun's ultraviolet radiation is still strong enough to burn your retina, and you won't feel it happening. Take care of your eyes. They're the only pair you've got. There are several ways to safely view a solar eclipse when part of the sun is visible. You can install a solar filter on a telescope. These filters look like mirrors because they reflect a large percentage of the sun's light, allowing a safe amount through. When using a solar filter, always put it in front of the forward lens to block sunlight before it enters the instrument. With a properly filtered telescope, you'll be able to see sunspots in detail. Some people use a telescope or binoculars to project an image of the eclipse. Use extreme caution with this technique. Serious burns and equipment damage can result if it isn't set up properly. And it should go without saying, never look at the sun with an unfiltered telescope or binoculars. You can project an image of an eclipse using the pinhole technique. Poke a small hole in an index card, then use it to project the eclipse onto another surface. You can also make a personal solar projection hood with a cardboard box, aluminum foil, and some tape. Nature provides another projection technique. You'll find hundreds of eclipse images in the shadow of a tree as light passes through gaps between the leaves. And finally, you can purchase solar eclipse viewing glasses from your planetarium or online. Today, we can enjoy eclipses with the predictive power of astronomy. NASA's Goddard Space Flight Center provides solar and lunar eclipse predictions for the whole world. On August 21, 2017, the shadow of a total solar eclipse traveled across the continent of the United States. Everyone in the United States, Canada, Mexico, and parts of South America had a chance to see a partial solar eclipse. People situated on the line experienced totality, and millions marveled as they stood in the shadow of the moon. The total solar eclipse of 2017 was truly an unforgettable experience. The next solar eclipses in North America will be an annular solar eclipse north of the Great Lakes on the 10th of June, 2021. An annular solar eclipse crossing from Oregon to Texas on the 14th of October, 2023. And the total solar eclipse crossing from Mexico through the United States and into eastern Canada on the 8th of April, 2024. Several lunar eclipses will occur in the next few years. These will vary in depth, timing, and visibility. But if you can see the moon, you can see a lunar eclipse. Once feared, now revered, these rare and beautiful events have captured the imaginations of people throughout history. Where will you be during the next eclipse?